Tip number 2. Keep my opinions to myself. All right. We're doing simple and compound interest. Simple interest is no bank uses this. Maybe your friend, if they're named Lincoln, will do it. All right. Compound interest, this is typical. This is the bank. This is how the bank figures out how much you owe them. And compounded continuously. Banks can't do this because they can't do it infinitely. However, there is something that is charged continuously. Anybody know? The national debt is calculated using this formula. So that's the most interest you're going to end up paying. All right. So let's talk about what these letters mean. So you know what A is, that's the amount. P is the principal. That means it's the amount of money you invested or the amount of money you borrowed. Okay? R is the interest rate. When it says compounded periodically, we're talking about how often during the year is the interest calculated. How often. So you can call it semi-annually. That means you're charging interest twice a year. It could be monthly. Then you're being charged interest every month or 12 times a year. And that N is how often per year. T is the number of years. Okay?
What was R?
R is the interest rate. Like, let's say you have a savings account that earns 2% yearly.
Wait, N is what?
N is the number of times per year. N is the frequency per year. All right. So example 3A, that's a simple interest. Notice it actually uses the words simple interest. Okay? Simple interest. Bob borrows $6,000 from his parents. Why is it not focusing? But they're charging him 18.5%. That's not particularly low. Okay, he must pay them back in 5 years. So all you're going to do, using this formula, the P1 plus RT, so the amount, the principal is $6,000. 1 plus the rate is 18.5%. What is that in decimal form? It's 0.185. And it's in 5 years, so it's times 5. And that's what you put in the calculator. Alright, so that's going to be 6,000. 1 plus 0.185 times 5. So you can put it just like this on the calculator. Alright, you do just like that on the calculator. Okay, when I write it down, I use parentheses, but in the calculator, I just use times there. Okay? Press enter, and the answer is $11,550. So you borrowed $6,000 from your parents, but you have to pay them almost $12,000 back. That's what interest does. That's what interest does. Okay?
That just sounds like you have sucky parents.
No, they're just teaching you a life lesson.
That's a very high interest rate for a life lesson, and you ain't getting that back.
Almost $12,000. All right, example B. You invest $6,000 at 6% simple interest. I don't know where you're going to do that. If you find that place, please let me know. Well, actually, that's a ripoff. Simple interest. If you're on the receiving end of it, that's actually the worst one. So it's 1 plus 0.06 simple interest times 10. So it's times 10. 10 years. Calculate that. I smell corn.
Corn?
Somebody eating corn?
Oh, I smell corn too.
Like buttered corn. Oh! Alright, answer is $9,600. Oh, that's not bad. You get $3,600 back? But I don't know anybody who gives you 6%. Actually, I don't know anything about money.
I have none. Oh, actually, I have $1 in my wallet.
Alright, ready?
I want to be a debt collector.
debt collector. You don't have enough mass. You got to be able to tackle those people if you're going to be a debt collector.
I'll hire some guys to do
Oh, I
it.
got you. All right. Now this one. Pay attention to this one. There's two questions here. I'm investing $10,000 at 2.5% for 30 years. There's two compounding. There's one compounded quarterly and one compounded continuously. So compounded quarterly, that means how many times per year? 4. So that means n equals 4. So for compounded quarterly, n equals 4. Okay? So my principal, my amount is 10,000. Right? I'm using this formula. This is the one that's compounded periodically. So it's 10,000. 1 plus the interest rate is 0.025 over the number of times it's compounded per year. Raise it to the 4 times 30.
Oh, you gotta raise it to the. Oh yeah.
Yeah, you're raising it to the 120th power. All right, let's put that in the calculator.
That's ridiculous. It's ridiculous.
Let's see. Well, if you're investing that kind of money, that's not a bad deal. 10,000.
Imagine having to pay
1
money.
plus 0.025 over 4 raised to the. Wait. I did that wrong. I listened to somebody by mistake. It's plus 0.025 over 4. Exponent is going to be 4 times 30. I'm just going to put 120. And I got a syntax error. Oh, I got extra parentheses. Still got a syntax error. How come it didn't delete those parentheses? There you go. $21,120. Let me do that again. There's all kinds of weird mistakes on that one. 1, 2, 3. 1 plus 0.025 divided by 4. Raise it to the 120. Okay, that was right. All right, $21,120.65.
Wait, why do you divide by 4?
Okay, that's the formula. Divide by the frequency. You divide by the number of times it's compounded per year. It's compounded quarterly, so I divide by 4. Alright? So that is $21,120.65. Alright. Now, if you're going to compound it continuously, you're going to use the Pert formula. You're using this formula. This is the Pert formula. Looks like Pert, right? So the principal is 10,000. E, you're going to actually use the letter E. Raised to the R. R is 0.025. And T is 30. So times 30. So it's 10,000. 10,000. 1, 2, 3. E. E on the calculator goes like this. You're going to hit the second button. And there is the ln. See the blue E to the X on there? That's what you're going for. ln. So that's what happens. And it's 0.025 times 30. Press enter. And you get that mess. You get $50 more. So it's $21,170.
Is it always $50 more?
No. It's always more, but not that much more.
We have to have both of these answers.
They had 2 questions, so I have 2 answers. Alright, example D. Warren purchased a car for $14,000 at 4.9% compounded monthly. Compounded monthly. How many months in a year?
12.
12. So it's going to be 14,000. 1 plus, the rate is 0.049 over 12, because you're compounded 12 times a year for 72 months. That's the exponent. 72 months is the exponent.
That's a lot of months.
It's 6 years. Okay. Usually they'll say, well, actually they'll usually say months. So use the months.
I don't quite know how to calculate it.
What do you mean?
That doesn't make sense to me where you can put like the hardest math problem ever and they know it.
Somebody wrote a program to handle all that.
Really? Yeah, so this is like actually that calculator right there I developed in Miss Lafayette's fundamentals of computing program last year. Yeah.
Alright, plugging in the calculator, 14,000. Parentheses 1 plus 0.049 divided by 12. Raise it to the 72.
Wait, so they wrote like 1 plus 1 equals 2, 2 plus 2 equals 4, stuff like that?
Yeah, there's something called an addition engine. Where you have a system where you can add, and you're only adding ones and ones and ones and zeros. So even 7 plus 6 is 1, 1, 1 plus 1, 1, 0, which is 1, 0, 1, 1, 0, 0. Something like that. I'm sure I said that wrong. Alright, so I'm getting $18,773.73. $18,773.73. What's that? Alright. Next question. E. When Jill was 27, she deposited $4,000 into an IRA where it earns 9.8% interest. And it's compounded only semi-annually. So how many times per year is semi-annually? Three. Twice. Alright, so it's 0.098 over 2. And if she's 65, how many years does she leave it in the bank?
A lot.
Oh.
Can you be more specific, please? How do you figure it out? 38. You just subtract. 65 minus 27 is 38. So 2 is the frequency of the compounding times 38. And that 2 times 38 is in the exponent. So put that in, 4,000. 1 plus 0.098 divided by 2. Close parentheses. Raise it to the 76. Alright, so I'm getting 151,000. That's a lot of money.
Dang.
$151,704.02. $151,704.02. Alright, now there's another question. What will it be worth if it was compounded continuously? So probably like $50 more. So it's E. Oh, I put a parentheses for no good reason.
Dang.
R is 0.098, and the number of years is 38, so times 38. So put that in there, 4,000. E was it 0.098? 0.098 times 38. Okay, so that's what I put in the calculator. 4,000 times E to that mess. And I get, I get 10,000 more this time, 14,000 more.
What? I'm confused about compound continuously.
Compounded continuously is a different formula. So just use a different formula. So that was $165,719.13.
You said banks don't use compound continuously.
Yeah, banks don't do that. Unless they're charging you money. Alright, last example. This one's kind of hard. Alright, Margot opened a savings account 3 years ago at 0.0435. Compounded weekly. How many weeks in a year? 52 weeks in a year.
Just 52 weeks in a year?
Yes.
Oh, that doesn't even sound like a lot.
52 weeks doesn't sound like a lot.
No.
Alright. It says the current balance is $2,905.31. How much money? So that means I don't know what the initial amount was. It's compounded 52 times a year, so it's 1 plus 0.0435 over 52, and it's been sitting there for 3 years. So it's 3 times 52. So you got to figure out what this number is, and then divide by it. Alright, so let's figure out what this number is. So I'm just going to put that in here. 1 plus 0.0435 divided by 52. Raise it to the 3 times 52. Alright, so all I'm doing is putting that part in the calculator. Alright, I'm putting just the interest part. And that gives me this long number. Okay? Now, I want to figure out what the principal is. I have the current amount right here. So, since that's just a regular number, how do I solve for P? Huh?
I was just saying.
What did you say?
I promise it's not being said.
Alright, so all you're going to do is divide by that number.
That's what I said. Take the interest rate and divide.
Exactly, good job.
Yay. Divide by.
Alright, so I'm going to put in 2905.31.
2905?
Isn't that what that is?
Yeah.
Divided by, so what I'm going to do with the calculator, I'm going to go pick up the answer. And then divide by it, and it gives me $2,550. So that means P is $2,550.
Bye, Mr. Schweitzer.
Bye-bye.
Where are you going?
It's going back to FFA.
I want to go.
Me too. Alright, that's the end of the lesson and end of the video.